at the beginning if we didn't need to. So, okay, let's just talk just a little bit more about a few things. Let's see here. Why is it doing this? All right, so yeah, make sure that you're muted and that the hand icon is down now. Okay, and then just when you want to talk or when you have something to say, so there will be times when I'll be asking you guys questions, you know, please raise your hands. Like, I want this to still be an interactive class like it's always been, and I want your participation, and so please don't be afraid to speak up and stuff. It's going to be kind of different getting used to clicking on the microphone before you speak and stuff like that, but we'll get used to it, I'm sure. So So I want to talk a little bit. So I thought it was kind of really timely. You know, we just got done talking about exponential functions, and you've probably seen all over the news how this is really, you know, this coronavirus is growing at an exponential rate. And so it's kind of like interesting. And so I feel like you guys are, you know, maybe better educated on some of this than some other people are, and understand about exponential growth and how it can go up so quick. I mean, we've talked about viral videos and stuff like that, but we didn't, you know, we haven't really talked about viruses, but they're same way, right? And bacteria growth and stuff too. So first of all, and I know there's some biology people in our class that like are a biology major or taking those classes for pre-med or whatever. So does anybody know, like in the context of this problem, what does the word novel mean? Because you keep hearing that a lot in the press. Anybody raise your hand and tell me if you know what that means. Nobody heard that? I don't see anybody raising your hand. Nobody knows what that means? All right, well, I looked it up because I kept hearing it all the time, and I'm like, why are they calling this like this novel, you know, coronavirus? You know, it was like, does that, you know, just mean like it's just, you know, unique or something like that? And it kind of means that, but basically it's because this started with, you know, an animal, and usually, you know, diseases or, you know, things like this transfer from animal to animal, but then at some point, you know, this transferred from an animal to a human, and then from human to human. And so when that happens, like the swine flu happened that way too, and like the avian flu. So we've had a few things that have happened like that, but so that's why they always kind of say, you know, novel coronavirus and stuff. But I want to have you take a look at this. Let's see if I can. I feel like I need like 3 screens or something. It's hard when I'm trying to get all of this stuff on here for you so I can see what it looks like. Anyway, so you can kind of see this is, you know, a kind of an exponential curve that's happening with these active cases. It looks like something a little bit weird happened here, right, around February 12th or something like that, because it didn't stay like a nice smooth curve like it usually does with exponential growth. But then you can see now it's just going up and up and up, and so it's really quite amazing, you know, that we're living in this right now. I've never lived through anything like this before, where everything's shut down like this, and we've got to do this social distancing. And I'm sure, you know, like my daughter, she lives in Orem and goes to UVU, and she just doesn't quite get, like, why do we have to do all this social distancing? She's like, if I get sick, it doesn't really matter. But I'm like, yeah, but if you made somebody else sick, you'd be feeling really bad, like your grandparents. So yeah, so it's something that, that we're not really used to and we haven't seen a lot of. But so we hear a lot about this flattening the curve, right? People are, saying, okay, we've got to flatten the curve so that we can make sure that this doesn't spread as fast. And so that's a little bit, I wanted to show you something that I found, and maybe, some of you have seen this already, but so if the cases of the coronavirus were to continue to double every 3 days, there would be 100 million cases by May in the United States. And that would happen if we didn't do any self-quarantining. And so it's really important. And so by doing this social distancing, we can slow the spread of this. So I thought this was really interesting, and I want to know, your kind of thoughts about this. Let me pull up this next thing. See, it's thinking. All right, so in the Washington Post, they had this really cool article, and maybe some of you saw it, but they were talking about how to flatten the curve and why it matters. So if you look at this, right, this is showing the exponential growth, and this is what we've been talking a lot about is exponential growth. So it's like so applicable to what we've been doing. But then they talked about, okay, if there's healthy people, and they're going to represent these little kind of bluish dots, and they come in contact with a sick person, then they get sick, right? And then those sick people will pass it on to other people. And then there will also be people that after they get sick get recovered, and those are going to be these little purplish dots. So in this first simulation that I'm going to show you down here, this is, just, what would happen if we didn't do, it was just a free-for-all and we didn't do any kind of social distancing. And that's what was happening at first, and that's why things got so bad in Italy and in China and even in New York. So watch this little simulation. So these, remember the brownish orange dots are the sick people, and as everybody's moving around, right, everybody's getting sick. And you notice this graph, right, you can see this exponential curve that's going up, right, and then at some point, right, people will recover and it'll come back down, right. It doesn't show anything about those that have died or anything like that, just kind of recovered and stuff like that. But it's really interesting. So look at how steep that is right now, and how there's like no healthy people left, right? And so this next simulation, I thought was really cool too. And this is like, well, what if, people did decide to do a little bit of, quarantine. So if there was a forced quarantine, and so the Chinese government decided to implement that, but it was kind of a little late when they decided to do that. So over here is where, people are being quarantined, but at some point, right, people start going out. And so all of these people over here were totally healthy, but then as the sick people start to come out, right, then it's getting more and more people sick, but people are still recovering, so that's good. But look at what happens here, right? I mean, so we still get a ton of people doing this. And as you do these simulations, you'll get a different thing every time, because it's just, it's just random where these dots are hitting each other and stuff. And then this next one was, what if a quarter of the people were asked to, stay home and not go out? And so doing this social distancing. So that's what this would look like. So notice that, a quarter of the people are still moving. 3/4 of people are staying inside. And look at how slow, right, the spread is. I mean, people are still getting sick, but not as quick. And so this is something that the healthcare industry would be able to handle, right, if we had something more like this. And then the last one is, what if only like 1 in every 8 people were moving around? So if we even did social distancing some more, how that would change it. So And so I thought those were kind of interesting and how those kind of changed there on this. But I want to hear from some of you about this. And, since it's just, we've been talking about exponential growth and you hear a lot about this flattening the curve. So, so these are kind of what happened in our little instances here, right? Free for all, attempted quarantine, moderate distancing, or extensive distancing. So what have you guys, what have you heard, or, what do you think about this whole idea of the quarantining and, the social distancing and stuff like that? Remember, we're going to be interactive. I want to hear from you guys. I can hear you, Rebecca. Great. Oh, yeah, yeah, yeah. How it can slow that down. Thank you, Nikki. Hey, Rebecca, you had something to add too. Mm-hmm. Exactly. Yeah. So I'm curious if, because what you said is, you don't know anybody that's sick. Raise your hand if you guys know anybody that's sick. So Rachel does, Liliana does, Riley does. So there are a few people that know, like, and they could be like, distant out. Like my husband knows somebody also, and his family. It's not, I don't know him, and stuff. But so yeah, I mean, it's getting around, and it's, like Rebecca said, we really need to do our part. And so even though this is frustrating, it's so hard. We're thinking about like trying to learn this way, and people are like, I don't want to do this, but there's good reason for it, and you can really see it, when they do some kind of like simulations like this, so you can kind of understand maybe a little bit better why that's going to help us in the long run to be able to do that. All right, move that out of the way. Come back over here. And so, yeah, so when I did this before, these were what my, curves look like and stuff. And so I just posted them on here so you could kind of look at them. But I wanted to show you, like, notice that on this one, like, this is really like, this is exponential growth going up here. And then at some point it'll flatten out, and then you'll have that exponential decay. So you do get it on two sides, but that's what's going to happen if everything's just kind of a free-for-all. But this is more, we want this extensive distancing, to happen there and stuff. So, sorry, my mom's trying to call me. Trying to let her know I'll call her later. This is going to be interesting. Yeah, but we want to just get this, curve flattened, and that's going to help us, out, and it really will be so beneficial. I don't want to get into the, to the situation where Italy is, or, even New York. I feel so bad for them right now and all that they're going through, and I just don't want that here. It's going to be, crazy if we, do that. So, yeah. I agree. I agree. I mean, I feel fortunate because, I mean, I live in Heber City and, and I have like walking trails in my backyard, and I feel like, because I'm going crazy. I'll just tell you, I'm going crazy staying in. But I mean, I like trying to go for social distance walks. Like, I'm like, I've got to get out and I've got to do something, but I don't want to be around like a lot of people. So that's, something that's helped me to kind of cope with it. But yeah, and you'll see, I mean, homeschooling our 8-year-old and stuff. So, I'm sorry if he comes bursting in, during this sometimes because he probably will, with a question or something like that. So I understand that you guys' lives have changed and, that you're trying to, figure out what you're going to do now. And so, all right, I want to know want you guys to try. Do you guys have like your phones or something handy? Or even you could just go, on your computers, if you're on your computers, and then just go to student.desmos.com and then type in this little code here. And you don't need to sign in like using anything. You can just say, skip sign in or something like that, and it'll just have you put your name in it. But we are going to be doing some Desmos activities, and so I just wanted you to try a little something out together to make sure that we can get in this. On this one, you can just put your first name, that's fine. When we do activities that you'll be graded on, make sure you put your first and last name in. It doesn't matter, actually. So BCZ 2KX. Has anybody been able to get in? I know. It's kind of... You need it again? That's fine. I was just trying to pull this up, but I'm going to kind of move it out of the way here for a second. There you go. And remember to mute yourself if you're not currently talking. I know it's going to be hard to kind of get used to that. My mom was calling because she needs math help for my nieces that she's watching. Okay, so let's see. Somebody has their microphone on still, and we're getting feedback. So everybody check your microphones right now. All right. So, oh, I still hear it. Let's see. Nikki, you're not muted. And Luciana, you're not muted. Yeah. So go ahead and mute your Do you see how to mute it? Just in the participant box, if you just click on the microphone on the far right side. That's the easiest way usually. All right. Let's see. Nope. Luciana, I think yours is giving us the feedback. Try and click on your microphone. It's okay. Okay, there we go. All right, so it does look like I'm having these same feelings. I don't know about you guys, you know, like depressed, bored, stressed, right? Wow, Lily, you're happy? That's good. Tired, chill, right? Stressed. I want to go out. I hear you, Monica. I totally want to go out too, right? But, you know, hopefully you guys won't be so bored now that you'll have some math homework to do. You're like, yeah, Becky, that will really alleviate my boredom, I'm sure. So, all right. Let's see here. So just know we are going to be doing some little Desmos activities like this. This was just one to just try it out and kind of make sure, you know, everybody knows how to use it, how to get into them. Because I still, like I said, I want to do interactive things with you guys, and I've been trying to figure out ways that we can do that. And so anyway, so I'd love your feedback too on some of these things that we do, because I want to make sure that they are things that are going to be helpful for you. And if you're, you know, if there's so many, you know, I mean, I know not everything's going to work for everyone, but if I hear from a lot of students like, that's not helping me, I'd rather do this or that, just know I will listen to what you're saying, and like I said, I'll, you know, try and help you do what's going to be best for you, or at least the majority of the class. I wish I, you know, could do it for everybody, what's best for them. So let's see. Let me go to, I want to talk next, and I know kind of the beginning of this, I was wanting to do some things because I knew there might be some students that might not get in on time and stuff like that, but also I'm concerned about you, worried about you. I want to know, you know, how you're doing and, you know, what I can do to help you. But I want to let you know that we are going to be doing the test, but it's going to be a take-home test that we're going to be doing. And so we kind of went back and forth, the math department's still trying to figure out what we're going to do as far as the final exam goes. But for this exam going forward, just know I'm going to be sending you the take-home test, and I would like that uploaded to Canvas. It needs to be uploaded there by March 30th, and so I'm going to get that out to you guys today so that you can start it. You'll have the weekend and stuff like that. And please reach out to me, like, you know, if, you know, I know all of you have different things going on and stuff like that, and just know I'll be flexible and, you know, and helping you get through this. But I'd like to get those done by March 30th if at all possible. But if you have some real big conflicts and stuff like that, just reach out to me, let me know. But just know, so for this test, because I know not everybody has a printer, if you do have a printer and you can print it out and write right on the test, and then scan the test and upload it. And hopefully all of you saw that I put that, there's another module in there that's, you know, talking about the, what did I call it, like remote learning or something about that, transition to online or remote learning. And it just gives you a few tips and stuff. But there are 2 assignments in there that you need to do, because I want to make sure, one, that you know how to change your notifications for Canvas, because this is the only way I'll be able to get a hold of you now. And so make sure you do that. Change your notifications like it says in that assignment. And then also the other one is converting like a picture to a PDF, because it's going to make things a lot easier if you can do that. So they have some great apps out there, so please make sure you read through those. And if you don't have, you know, something submitted in just one document, I'll make a comment or, you know, say resubmit this, you know, as one document. So if you're struggling with figuring out that technology and stuff, just reach out to me and I'll help you with that too. But so if you can print it out, great. Right on that. If you can't print it out, I know some of you have tablets. You could write it on there on your tablet and then take pictures of those and upload those. Or you could just, you know, write out the questions on just lined paper and then just make sure it's neat and everything like that so I can read it. I can tell which question's what. So I just want to work with you and understand that not everybody has, you know, access to everything now, that we know longer, you know, or we have to stay in all the time. I mean, the computer labs are still open on campus, but I wouldn't be surprised if they might close those down at some point. They're trying to keep them open, keep them sanitized and everything like that, so people can use them if they need to, but just know that those are still open right now for you. So so like I said, I'll get that out to you today. It'll need to be returned to me, uploaded on March 30th, by March 30th at midnight. Okay. And then I'm going to try and have those graded and back to you. So I will submit those back to you, and you'll see them in your grade book, and you'll be able to click on it and see the feedback and everything that I give to you on it. So just know that that's going to be there. Any question about the test right now before I go on to the next thing? Let's see, Monica? Yeah. Well, I mean, that's a good question. Like, I'm not going to know, but remember that your final exam is worth a lot of your grade, and that one I know you won't be able to do that on. So, so yeah, and then just, you know, think about how, you know, you guys need this material for your next class, and so it is really important. And I know some people are like, I just don't want to, you know, do math and stuff like that, but, you know, I mean, I'm going to have you sign a little, you know, thing at the top of the test saying that you know, are being honest and not cheating on it. So that's the only thing that I can do, but then it's just up to you guys, you know, to be, you know, just be honest. I trust you guys, and, you know, and I know that you want to learn this stuff for, no notes, and it'll say that at the top of the test. So the only thing that you can use, just like in the classroom, would be your scientific calculator. So everything else should be just kind of put away, and, you know, so yeah, and I appreciate you, you know, asking that, because it is hard sometimes, and different teachers have different expectations with take-home tests, but this one is, you know, just going to be kind of like you're just doing the test at your house instead of in our class, but all the same expectations as if you were doing it in our class would be there. And so I will also suggest that you do it in one sitting, rather than, you know, spread it out over, you know, some time, because then that might encourage more, you know, dishonesty and stuff like that. So just find yourself, you know, like a 2-hour time block or something like that you are going to take this test on, and just do it that way. So thank you. Let's see. Monica, you had a question too? No, so I will get it out to you today, and so you'll have from today until the 30th at midnight to get it uploaded to me, so to get it finished and then uploaded. Yep, but you make sure you show all your work and everything. just like it was on the test. I'll still expect that work to be shown, but just nice and neat. So I'll be able to, because if I can't read it and stuff like that, then, you know, more likely chance that you'll be missing points. So try and make it really legible for me. You know, and I'm not expecting perfection, but I just don't want scribbles and stuff like, oh, go up here and then down here, you know, like just make it very succinct and that'll be just fine. So, okay, thanks, Monica. Was there another question? I thought I saw another hand. Maybe we got that answered. All right, and let's see, did you put down your hand now, Monica? Yeah, thanks. Okay, so the next thing is I wanted to talk about that car comparison project. And some of you had started uploading those to Canvas, and I'm trying to remember, did I have it made due? I thought it was the 31st. I didn't write down when that was due, but I'll send out an email kind of reminding you about that. But the one thing I wanted to make sure, because some people were saying, you know, I want to make sure I'm doing this right. Can you, you know, check it over and see? But I made a very detailed rubric that's on Canvas. And so when you go into the assignment, you can view rubric and you can tell if you are getting, you know, all of the points or not. You know, like on the graph, you know, I'm like, do you have the axes labeled? Do you have your graphs labeled? Do you show the point in which these are connecting? So it's very detailed. And if you follow those things, you will get full points on it. Okay. And make sure that your reflection is more than just like a one sentence thing. Like, remember, you're trying to convince the, you know, this company that this is the better option. And so I expect a reflection about it to be like, you know, this would be the better option because of this and this and this, and really, you know, expand on that idea, right? And remember not to upload anything to your actual e-portfolio yet. That'll be a different assignment that we'll be doing after I give you feedback on this assignment. So just get it uploaded. Let's see where you're at. I'll tell you what changes need to be made. And also from the ones that were submitted already, and I didn't mark off any points for this, but just for those of you going forward, when you're writing down your ordered pair, let me see if it'll let me write on here. You know, so if you have something like you know, maybe like 52 and then like 31,800. So when you have this other comma there, you know, in between the 1 and the 8, it makes this look really strange. So I would suggest when you write those down, just do 52 comma, then put a space there, right? It'll make it look a little bit better, and then just do the 31,800. All right, so that's a space, not a negative sign. It looks kind of weird there, but I'm just saying, put a space there and don't put the comma in between, because then the ordered pair just looks kind of weird. And we haven't dealt with numbers that big before, and so I haven't had the opportunity to kind of tell you that. But like I said, those of you that already uploaded it and stuff, I didn't take off points for that. I just said fix this before you put it on your e-portfolio. Okay. Any questions about the car comparison project that I can help you with? And if you have specifics on your project, please come to my office hours and stuff like that so I can help you individually with that. Let's find a time where we can do that. But I'm just saying, like, overall, do you know what to expect as far as, you know, when to turn this in, how to turn it in, and what's expected of you? Any questions on that? I think that's what it says. Is there anybody able to go in online? I've just got so many things open right now that it'd be hard for me to get in there. Okay. Yeah, that's what I was remembering was the 31st, but I didn't write it down. So, okay, any other questions on that? I'm excited to see your car comparison projects. Some of them are going to be, you know, closer, like the amount of months that it takes, some of you might, see, oh, wow, that's only going to be maybe a couple of years. This one's about 4 years, but some of them will be closer than that. And so it's just kind of interesting seeing how hybrids and the regular cars, like the prices have gone down so much on them that it seems like, it's more worthwhile doing it now, where a few years ago it wasn't at all, worthwhile to get it seems like. Yeah. Yes, so you need to actually, you can either take like a screenshot of it, or you can kind of do a little snippet. And if you're not quite sure how to do that, that's one of those things that you can reach out to me individually about. And then you actually need to, insert it into the document. So, okay. Okay. Good question. Yep. Okay. Any other questions on that car comparison project? All right. Yeah. Oh, sorry. Yeah. So, yeah, and it should be in the morning. I wouldn't be doing them from 11 to midnight. I won't be worth anything at that hour. So if I did put that, sorry, no. So Monday and Wednesdays from 11 until 12, or when I have them set up. But then I also was going to set up some times on, maybe a time on Friday or something. Thursdays are kind of hard because I teach this class, and then right after it I teach another class. I wouldn't be able to do anything until in the evening, but then I also have office hours for those classes then, because now I kind of have to do them separately since, I want to help people that are dealing with the same class at the same time. So if you have a suggestion, if there's some time on Friday that you think would work best, as long as it's not like really Friday night, I don't know. I'm kind of done by then. I don't know about you, but, Friday maybe before 5 p.m. or something like that, if there's a time that would work, just send me a message and stuff, or another time. But like I said, if you can't meet at those times that I have, just send me a message and I will find a time to meet with you. It's not a big deal. Okay, so now we are going to get into new content of what we're going to be talking about. So we just did exponentials and logs and stuff like that. You did some reviews with it. There's reviews online. They have, questions and stuff. And I think it'll make it maybe a little bit less stressful having it as a take-home test, I hope. But just review over those reviews that I gave you, and if you know how to do the questions on there, you will be sitting really good for the test. I'm not trying to make the test really, tricky or anything like that. I want to just make sure, do you have the idea? Do you understand exponentials and logs? Okay. And there will be a little bit on linear functions also, because I want to make sure that you can tell the difference if you're given a story problem. Is this a linear, growth, or is this exponential growth? So just expect that on there as well. But that was on the reviews as well. Okay. All right, so let's get into this. So hopefully you have your books right there by you, and we're just going to be, what page is it on? I know it's not 112 in your book. Can somebody tell us what page that is? 105? Okay. So if everybody will get there to page 105. Let's see here. All right, so we're going to start talking about quadratic functions. So all of chapter 7 is going to be along these lines with quadratic functions and understanding what they are. So we talked about linear functions, right? And the look of linear functions are always just some kind of a straight line. Exponential functions kind of look like this, and then log functions kind of look like this. So those are the ones that we've talked about so far, but quadratic functions are going to have a different look to them than these other functions that we've talked about. So what I want you to do on this first one, and we'll do this first one together so you can see, we're just going to do a table of values, but we're going to pick our x's in such a way that it's going to be most beneficial to us. We want to pick efficient x's, not just, any random things. And so the way we're going to pick efficient x's is we're just going to look at each of these factors. So make sure we understand. So a factor, right, are things connected together by multiplication. So x is one factor and x plus 8. 8 plus x is the other factor, right? So first thing that we want to do is look for a number that will make one of the factors 0, because that's going to actually make things easier for us. So do you see if I actually choose, oops, let me plug in my computer, I thought it was already plugged in. So if we pick something like 0, right, that's going to make this part 0. So I have 0 that I put in place of x on that one times x plus 0. So that's going to be 0 times 8, right, which is just 0. Or sorry, yeah, okay. Because this is going to make it like a little bit easier for us here. So I have one of my points on my graph is 0, 0. I put 0 in and I got 0 out. Okay. But now I'm going to look at my second factor here, this x plus 8. So what number could I put in place of 8, or in place of x, to make that whole thing go to 0? Somebody have an idea? You can just unmute yourself and say. So what? Yeah, so what number could we put in place of x, right, in just the second factor here, that would make that whole factor go to 0? Yeah, so negative 8 would be another good choice. So everybody look at that and see if you can see why negative 8. Because when we put, so I'm going to put negative 8 in place of both of my x's there. So I've got negative 8 times, and then 8 plus 8, or plus a negative 8, right? And that's going to give me 0. And 0 times anything is still 0. Right? So my next ordered pair is negative 8 comma 0. All right, so we have those two, all right, but then we want to pick another one, and we always, another good one to pick is, so figure out what factors go to 0, right? Makes one factor 0, makes the other factor 0, and then we want to pick a number that is halfway, right, smack dab in the middle of 0 and negative 8. So what number would that be? Yeah, negative 4. All right, so this is going to be another point that we want to pick on this. So let me just write a few things out to the side here after we do this. So let's put negative 4 in. So negative 4, right, times 8 minus 4. So I've got negative 4 times 4, which is negative 16. So I've got the point negative 4 comma negative 16. All right, and let's plot these 3 points right now so we can see what that's looking like on our graph. All right, so 0, 0 is about there, over negative 8, up 0 is there, and then negative 4 down to negative 16 is there. Okay, so, and I mean, 3 points on this could be, a good amount. We're going to be picking either, somewhere between 3 and 5 points on this, but I can pretty much tell what the shape of this graph is going to look like. Hopefully yours might look a little bit better than mine. This is not supposed to be a V, it's supposed to be a U at the bottom there. Hard for me to do on here, and these should be straight lines, not all squiggly like that, okay? But make sure it's kind of coming down as a U shape here. If it comes down as a pointed V, that's actually a different type of graph, okay? So I'm just going to put that up here to make sure everybody remembers, right? So these quadratic functions are always going to be U-shaped, okay? Or they could be upside down U, so they should look like this, or like this. Right? They'll always have this same look to them. Okay? Now, these points that we picked over here have a specific meaning to them. Oops, that's not what I wanted to do. Let's see if I can write to the side here. So this first one represents an x-intercept, right? Do you see how that is crossing the x-axis, right? So by picking something that makes one of those factors goes to 0, gives us an x-intercept. And that also is true here, right? We have 2 x-intercepts, right? Now this point, the 0, 0 point, is also our y-intercept, right? So it happens to be both on this one. But if it wasn't, we'd actually find another point where that y-intercept would be, okay? And then the other one that we did, so this halfway point, right? Do you guys get what I mean by halfway? Because I'm talking about halfway in between, right? So 8 and 0 is right here. And this is always going to tell us where the turnaround of the parabola is, right? So that's our turnaround point, or we're going to call that the vertex. All right, so these are important parts of parabolas, and it makes it really easy for us to figure out what the parabola looks like if we're picking these in such a way that, it's more efficient than just picking any old x's. Okay. And then also we'll be talking about how parabolas always have something called an axis of symmetry, and that always is going to go through at that halfway, that x that's halfway in between there. And this is the line x equals -4, right? Because remember when we talked about lines that are straight up and down are x equals some number, and it happens to be -4 on that. So if I ask you what the axis of symmetry is, right, then you're going to give something like x equals something, some number. All right, and that just means if I was to fold this parabola over on top of itself, if I fold it on this dotted line, that the parabola should land on top of itself. And you'll just have to use your imagination for mine because it doesn't quite look like that, but that's how it should look. All right, what questions can I answer about that first part? I want to make sure I have everything clear on what we're trying to do on these, since this is a new concept. Okay, Rachel? Yes, we are. Thank you. That is correct. There will not be any homework on Chapter 6. You will not be tested on Chapter 6. Okay? Thank you for bringing that up. I meant to mention that. Okay. All right, well, let's go to the next example. Oh, let's see, Nikki had a question first. I know. It's going to be tricky, and we're going to, it's going to be different for sure. But like I said, make sure you're speaking up if you have questions, because somebody else in the class has those same questions, and like you said, it's going to be tricky right now learning this way, and so I really want to make sure that you guys are feeling like you can do this. Okay, so let's look at this next one, and we're going to start it off kind of together, but I'll have you finish it up individually to see how you do on it. But so remember, we want to pick values, these efficient values, where each of our factors, right, we're picking our x's so that each of these factors will go to 0, because I know 0 times anything is 0, and that just makes my life easier if I have it written this way. So somebody tell me one x value we would want to pick. Go ahead and just say out loud on this one, if you know. What would be a good x value be to pick? Okay, we could pick 1, but would 1 make either of those two factors go to 0? So do you see if I did 1 here, 1 minus 4 is -3, 8 plus 1 is 9. So, yeah. And that's really what a lot of these are going to come down to, is just thinking of it that way. I'm glad you said it that way. So we're going to pick 4. That would be an efficient value. What other one? -8, right? Because that's going to make this one, this second factor, go to 0. Right? And then we're going to pick the halfway point. So what's halfway between, right, our 4 and our -8? Yeah, so we want to pick -2 as another x value. Okay, and then there's one other point that we're going to pick on this one. So remember, this one's making an x-intercept. Well, both of these are, by picking them in such that way. This one is going to tell us the vertex. And then this last one that we're going to pick it so that we know the y-intercept. We didn't do that up here because our x and y-intercept was the same point. And that is going to happen, you know, when you have something like this, where you have like a 0, 0 or something like that. Okay, that's when you have 0, 0, the x-intercept is that and the y-intercept is that. Okay, so who remembers, how do we find what x-intercepts are? What do we pick for our x? Do you remember? Let's see. I thought I heard somebody raise their hand. Somebody have? Rebecca? So we're not going to put so the y value isn't 0, but the x value is. So remember, so to find x-intercepts, or sorry, I meant y-intercepts, you let x equal 0 and solve for y. Do you remember that? So let's pick, so we're going to pick, we're always going to have our x is 0 is going to be another point that we're going to pick, because that's always going to tell us our y-intercept. Okay? Okay, so let me just stop there a second. Does everybody see why we're picking these points? And if not, I know you're not alone. So please, like, raise your hand and ask a question, and, you know, if you need some clarification. Yeah, let's make sure. And actually, let me have a volunteer, because I think sometimes hearing it in different words might help. So somebody that feels like they understand why we picked these x's. Will you tell the class what you're thinking there? I'd really appreciate hearing somebody else say it. Come on, I know some of you know. Even if you don't know all of them, but you can, like, I know this one and this one, but I don't know why we did that one. Okay, let me say it again and let's see if we can figure it out. So First of all, do you understand what I mean by factor? So maybe we need to start with that. So when I'm talking about factors of any number, right, if I said like 3 times 5 equals 15, the two things that are being multiplied together are our factors. Okay? And then the answer to a multiplication question is the product. So these are things that you've seen in other math classes, but they still apply here. So if you have one thing multiplied by another thing, those are factors. And so that's what we have in this case up here, right? We've got this x minus 4, and then we got the x plus 8, right? Or 8 plus x. Sorry, I said that backwards, but and so those are our factors. So we're breaking it down. So forget about the second factor for the first one that we're looking at there. We're just focusing on this first part and saying what x will make that go to 0. And I like the way Nikki said it is. She said, well, aren't we just picking kind of the opposite? And remember when we did synthetic division and you were doing that, you were picking that opposite value. I said, what number will make that go to 0? And we're doing the same thing there. So, right, so it looks like it says -4, so we'll pick the opposite. It's +4, right? And what value here will make that go to 0? If I put -8 in there, 8 minus 8 gives me 0. And then this next one is always the halfway in between the two other x's that we picked, right? And that halfway point is always going to give us the vertex or the turnaround point of our parabola. And then we'll also pick our x to be 0 so that we can find the y-intercept. Okay, Monica. So if we just looked on it, like think of this as a number line here, right? If I had 4 right here and -8 right there, if I was to, count in, right? So like from here to here, that would be 4 places in. From here to here would be 4 places in. But but that we're still not to the middle point yet. So do you see that right here, I'd be 6 places. -2 is 6 places away from +4, and it's 6 places away from +8. And a good way to do that, because if that gets kind of confusing for you, you could do the average of those two numbers. So you know how to find averages is if you said, 4 plus -8 divided by 2, right? So if I add those two together, I get -4, and then I divide it by 2, I get -2. So that would be the new x that I want to pick. Does that help? Either visually or just mathematically, seeing where we're getting that point from. I'm glad you asked that. That was really good. You're welcome. Okay, other questions on that? Really speak up. Like, don't just be silent and be like, oh, I'll get it or whatever, because if you're not getting it now, it's going to make it hard to get it later. So just make sure you're speaking up, okay? All right, so I want you to finish doing this then. So if you haven't done so already, just like we did up above, right, I want you to replace your x's with the x's we listed and figure out what our y's would be to find a point on that graph. Okay, so let me give you just a couple of minutes to do that. Okay, so first of all, are these the points that you came up with? If you came up with something different and are not quite sure why you came up with that different number, please ask. Like I said, you're not going to be alone. Somebody else may have made the same mistake, and so you'll be helping a friend out. Okay, now let's just go ahead and graph those on the grid then too. And look to see if that's what you came up with for your graph. All right, what questions can I answer about graphing this quadratic? And these are called parabolas. Whenever we have a quadratic equation and we graph those, they make a shape that we call a parabola. Everybody get that? Should leave it there for one more minute. And if I move on too quickly before you get something down, please just speak up and just say, hey, Becky, can you go back to that? Because I can't see what what everybody's doing and what your work is. I'd usually be walking around the classroom and see what you're doing and how far you are. But since I can't do that, I need to rely on you to just tell me, I need a little bit more time on it, Becky. Okay. Let's see, so we're going to skip that one. I want to do one other one first before we talk about this next example. So just go underneath it in your book and let's just write another example here. So the example that I want to look at is going to say, I want you to graph, oops, I should have just said graph first. So let's graph f of x equals, there's going to be a little negative sign out in front, okay, and then parenthesis x minus 2, and then parenthesis x plus 4. Okay, and so that negative that's out in front, right, is really like a -1 that's out there. And so I would encourage you to, put that in as a -1 if you think, oh, I'm going to forget that that's really what it's meaning there. So we really have like this -1 out in front that's being multiplied. So really this time you're going to be multiplying three numbers together. You'll have -1 times whatever this number comes out to be times whatever this number comes out to be. All right. So we're still going to do a table of values. We'll just have to make our own over here, but that will be just fine. We can do this. So we'll have x, and we'll have f of x. And so first of all, I want to make sure that everybody is understanding how we're picking x's. So will one person tell me a good x value to pick and why you picked it? So go ahead and you can just, you don't have to raise your hand, just go ahead and unmute yourself and somebody tell me one. So look at it again. Do we want -2? Is negative 2 going to make that go to 0? So if I put negative 2 minus 2, yeah, so we want to choose a positive 2. Does everybody see that? Because that's probably the most common mistake that's made. All right, so I'm going to choose a positive 2. What other would be a good x value to pick? Negative 4 would be really good. And then what's another one? Well, or you could pick, or you could make the y-intercept, but do you know what the in-between one would be? So let's try and remember, if you're trying to find the average, right, of those two, you do 2 minus 4 divided by 2, because you're adding those together. So that would be negative 2 over 2. So that would be negative 1. And I heard somebody say that, but I want to make sure everybody understands how you're getting to that. You can either look at it pictorially or just find the average of those two numbers. Is everybody good on that, on the negative 1? If not, speak up. If you're still like, I'm not sure I'm seeing why we're picking negative 1. Yeah. Nope. It just stays there. Yep. We're not going to distribute it. Good question. Thank you. Because that would probably be like maybe a first instinct, because we've seen that before when we have that out there, but I'll show you why we're going to do it differently here. So thanks for asking that. Okay, what other x value should we pick? What would be a good value for x to pick? There's one other one. Yep, 0, because that's going to give us our y-intercept, right? So remember, these two, we're picking them this way because these give me my x-intercept. This one's going to give me my vertex, and this one's going to give me my y-intercept. So those are the things that I'm looking for. Those are the important parts of the parabola that are going to make it easy for me to tell what the shape of this looks like. All right, so let's go ahead and figure these out. If you put this in, let's do maybe this, do this first one together just to make sure you understand what to do with that negative 1. All right, so we're doing negative 1 times, and then you're going to do negative 1 minus 2, or sorry, I meant 2. Sorry, I put the wrong number in there. It's looking in the wrong place. Whoops. Okay, sorry, I'm putting 2 in place of my x, so I need 2 minus 2, and then in the other parenthesis, 2 plus 4. All right, but we've got a 0 here, right? So it doesn't matter if I times it by a negative 1 and times it by something else. Anytime you multiply by a 0, you're going to get a 0 answer, and that's the whole reason why we're doing it this way. So you should have the point 2 comma 0. Okay, all right, do the rest of them. just double check when you're done doing yours to see if you got those same 4 points. And see if your graph looks something like this. Okay, so why is this one, why do you think this one's upside down where the other two that we did were right side up? Maybe share with us why you think that might be happening. It is, right? That's pretty much the only difference that we had between the other ones is we didn't have that -1 out in front. So that negative out in front is actually making it, it's flipping that parabola upside down. So that's one thing that I want to make sure that you know is when we, have a negative or something like that out in front, you should expect to have an upside down parabola like this, okay? Where if it didn't have that, then we would expect it to be a right side up parabola. Okay. All right, what questions can I answer on that one? Are you feeling more comfortable with it? Raise your hand if you feel like you're understanding it a little bit better. If you're still feeling really not good with it, then keep your hand down. But if you're feeling like you're getting it, raise your hand so I can see. That's most of you. So those that didn't raise your hand, is there a question I can answer to help clarify? It looks a little different. It looks different because we have, we're like multiplying things together like this. We haven't seen something quite like that in the other equations that we have dealt with when we're graphing them. Okay, go ahead and put your hands down now. And let's look at this one right above it, right? So on this one, what do you notice that's different about the other equations from the one that we have here? Yeah, so we've got this x squared looking thing, right? What else? What other differences do you notice? Okay, they're not in parentheses this time. Michael, did you have something to add? Or is that up from last time? You can just put your hand down if you didn't. That's okay, no worries. Just want to make sure. All right, so yeah, so it looks a little bit different here, right? And so if we're trying to pick these values like we were doing before, right, we're trying to pick these x's so that we can find our x-intercepts, we can find our y-intercept, and we can find, our vertex, because those are the important parts of our parabola that we want to make sure that we know. But on this one, right, it's a little bit different because the only thing that we could really figure out when an equation is written in this form is we could figure out what the y-intercept is. We could put 0 in place here, and actually finding the y-intercept when it's in this form is a little bit easier. Because notice when we have this, if we put 0 in place of my x, I'll have 0 squared plus 5 times 0 plus 6. So 0 squared is 0. 5 times 0 is 0, and then 6. So we just get 6 for our answer. So it's always going to end up being that number that's there by itself, because those other two terms end up going to 0. So really, when it's written in this form, right, the only good point that we can tell right off is our y-intercept. And since it's positive, since that first term is positive, we know it's going to be a right side up parabola, but we have no idea how far down that goes, where it turns around, or anything like that. And so, so that's what we're going to kind of get to next, is what do we do with these, right? How can we change this to a different form so it's easier for us to find those x-intercepts and that vertex point? Okay, so we are going to, I know some of you kind of need to get up and stretch and take a little break, so I still want to do that on here. So let's do that. Get up and, I'll come back in about 5 minutes or so, and then we'll start back up again. And we're going to be doing another Desmos activity. On this activity, it will be easiest if you have a laptop. You can try and do it on your phone. You just won't be able to be as precise on some of them, just because of the way the phones are. But so I'll get that pulled up on here so you can see where you're going to be going to, what activity we're going to be doing. But take a little break right now. I'll just leave that up on the screen so that you'll know where to go to next. Let's see.